Hello everyone. In this video, I'll be using a current and voltage divider to find the current of this point, which I denoted by this arrow, and also find the voltage across this resistor, which I denoted by V0. And let's see how we can tackle this problem by using current and voltage divider. So in order to find the current and voltage, we need to find the total resistance of the circuit. And let's say the voltage source is 15 volts. So let's see how we can find the total resistance of the circuit. And if you notice, these three resistors are in a parallel, which means we can use the equation of resistors in parallel, which is R equals to 1 over R1 plus 1 over R2 and plus 1 over R3 and so on. And let's calculate this and see what is the total. Before I calculating these three resistors in parallel, I redraw the circuit that represent the two resistance, which is this one is 5 ohm, and we're going to find this one, which is the calculation of these three resistors. See 1 over 6 plus 1 over 6 plus 1 over 3. And I have a more detailed video of the series and parallel resistance and you can refer to that if you are not sure how you can calculate this. So the calculation of this three is 1.5 ohm. If I write this here, and this is easier you can see and easier to deal with. And if I write the voltage source, and so we are looking for the current, and you can simply use uh, the Ohm's law, which says I equals to V over R, and R is the total resistance. In our case, is 15 volt for the voltage source, and these two are add together. 5 plus 1.5 is 6.5, and we will get a of 2.31 ampere. I rounded to decimal places. All right, so if you see the new circuit and if you want to find the voltage of at this point, you can use the voltage divider and find it easy. So, but before I do that, I would like to emphasize a very important fact about circuit in series and in parallel, and which is when the resistors are in parallel like this, and let's see we have resistors in series. So you have to keep in your mind that the voltage across each resistor is the same. So same voltage. But in resistors in series, the current is the same. Current is the same. So by knowing this, you can now find the voltage of this point, which saying that when you find the current at these 2 points, doesn't matter if there are multiple resistors or just only one. That means when you find the voltage is applied to each branches. That means if you find the voltage of this circuit is equivalent to V naught. So let me clear here. So let me write the current source we calculated, and I just erased it, which was 2.31 ampere. All right, so let's see how we can find the voltage of these 2 points. And if you remember, the voltage divider is V naught or Vx equals to R naught divided by RT times the voltage source. In our case is we are looking for this voltage for this resistor, which is 1.5, and the total resistance is 6.5 times 15. It would be 3.46 volt. I rounded to decimal places. So we just calculate the V naught, and I wrote it here, and I erased the calculation for the voltage divider. Now let's see how we can calculate the I naught using current divider rule. If you remember, the current divider rule says Ix or I naught equals to the total resistance divided by R naught times I source. And you have to be a little bit careful here when we say R total or the total of resistance is not referring to the whole circuit, it's referring to the total resistance of these three resistors. So let me plug the numbers. So the total resistance of these three is 1.5 ohm, and for particular resistor we are looking is 3. And if you remember, the current through the whole is 2.31, and multiply by 2.31 ampere equals to 1.16. Let me write it nicely. We need it, or I can write it here. So 1.16, I rounded to decimal places, ampere. All right, so let's explain and emphasize how we got this and what is for the current for the other branches, and if we just making sure we got the right answer. Let me clear here. So we have to have the total current of each branch must be equal to 2.31. So let me find the total resistance of these three and make sure we got the right answer. So for this 6 ohm, we have again I not equals to R total R not equals times I equals to, so we have 1.5 for this one is 6 times 2.31 equals to 0.58 ampere. And because this one is the same value, this resistor is the same value for as this, so both are the same current going through it through, so 0.058 ampere. And for this one we got 1.16 ampere. If we add all these three, we should get 2.31. But if we calculate this, we get 2.32 because I rounded. So so I did this to make sure we got the right answer or the right current. So, and as you know, again, the current through these two must be the same. Thank you for watching. That's it for today.